am Mr. Explainer. I'm not from this world, but from a tidally locked planet named Dawn, present in the Skewer-Wheel galaxy. It is some 555 light-years away from Earth. I am very much fond of the various scientific topics and also like to explain those to everyone. In order to reach out to maximum crowd, I have started this YouTube channel named Mismatched Tapes. Don't worry, the channel won't be about explanations only, but will also contain numerous random but interesting stuffs. Today, I shall be explaining about the topic electrochemistry. So, listeners, I hope you will like this video. Let's get started. Well, electrochemistry basically deals with the chemical processes and electricity. It is the study of chemical processes that produces electricity. Now, let's study about cell. A cell is a single unit device which converts chemical energy to electrical energy. There are two types of cells. First one is electrochemical cell. It converts chemical energy to electrical energy. It is also known as galvanic cell. Second one is electrolytic cell. It converts electrical energy to chemical energy. In an electrochemical cell, the chemical reaction is spontaneous, which means the reaction proceeds on its own and we get electrical energy as the output. In an electrolytic cell, the chemical reaction is non-spontaneous. But how can we be so sure that here the chemical reaction is non-spontaneous? This is so because, in an electrolytic cell, we provide electricity as the input for which the chemical reaction is happening. Which means that the chemical reaction is not happening on its own. For a spontaneous reaction, delta G value, that is, Gibbs free energy, is negative. But, for a non-spontaneous reaction, Gibbs free energy is positive. In an electrochemical cell, the anode and the cathode are in different containers which are connected by the salt bridge. About the salt bridge we shall be discussing later on in this video. But, in an electrolytic cell, both the anode and the cathode are present in the same container dipped in the electrolyte. In an electrochemical cell, more reactive acts as the anode, which is the negative electrode, and here the oxidation takes place. Cathode is the positive electrode where reduction takes place. This is just opposite in case of an electrolytic cell, where the anode is positive and here oxidation takes place, and the cathode is the negative electrode where reduction occurs. One thing is very important to remember, that is, in both the cases, oxidation takes place at the anode while reduction occurs at the cathode. Don't worry, after seeing the sketches it will be clearer. Here, you can see the electrochemical cell on the left side and electrolytic cell on the right. Look, the electrochemical cell has zinc metal as negative electrode and copper metal as the positive electrode. V is the voltmeter. In the electrolytic cell on the right side, has both the electrodes made of copper metal. The anode is the positive one, while the negative one is cathode. I hope it's clear now. Okay, let's study more about an electrochemical cell. Example of an electrochemical cell is Daniell cell. It basically consists of zinc as anode and copper as cathode. Daniell cell has been illustrated here in this sketch. Look, it has two half cells. Left one is the oxidation half cell consisting of a zinc electrode dipped in the zinc sulfate solution. Here, zinc converts to zinc 2+ ions, losing 2 electrons, which are traveling through the circuit to the second half cell consisting of copper electrode dipped in copper sulfate solution. In the second half cell, the copper 2+ ions are gaining those 2 electrons and converting to copper metal. Thus, the reduction is occurring in the second half cell. Current is flowing in the opposite direction to that of the electrons. Here, you can see the salt bridge. It's basically a U-shaped device connecting the oxidation and reduction half cells containing an inert electrolyte like potassium chloride. Function of salt bridge is to complete the circuit and maintain the electrical neutrality in the internal circuit. Now, the oxidation half reaction is, zinc solid converts to zinc 2+ ion plus 2 electrons. The reduction half reaction is copper 2+ ion plus 2 electrons converting to copper solid. Therefore, the overall reaction, which is simply the addition of the oxidation and the reduction half reactions, is zinc solid plus copper 2 plus ion giving zinc 2 plus ion plus copper solid. The Daniell cell representation is shown here. The parallel line represents the salt bridge. On the left side of the salt bridge denotes the oxidation half, and on its right side is the reduction half. Now, as there is separation of charges, there must be potential difference, and this takes us to our next topic, which is electrode potential. Well, electrode potential is the potential difference developed due to the separation of charges between the electrode and the electrolyte. It is denoted by capital E. There are two electrode potentials. First one is the oxidation potential and the other one is the reduction potential. One thing must be noted, that the oxidation potential is the negative of the reduction potential. Again, the electrode potential at standard condition, which is when temperature is 298 Kelvin and for 1 molar concentration, is defined as the standard electrode potential, denoted by E0. The EMF of cell under standard condition is E0 cell is the sum of the E0 reduction cathode and E0 oxidation anode. But we have already noted that oxidation potential is the negative of reduction potential. Therefore, we can write E0 cell is equal to E0 reduction cathode minus E0 reduction anode. Don't get confused with the E0 reduction cathode or anode. It simply denotes the reduction potential of the electrode, which means the tendency of the electrode to get reduced. Now, if it is not a standard case, we simply remove the not symbol and get the equation, capital E cell equals to E reduction cathode minus E reduction anode. The standard electrode potential for Daniell cell is 1.11 volt. I think we have learnt a lot today. Let's wind up. So, what have we covered today? Firstly, electrochemical cell converts chemical energy to electrical energy, and the opposite happens for an electrolytic cell. Secondly, we have studied that oxidation always takes place at anode while reduction occurs at the cathode. Then, about the Daniell cell, which has zinc as anode and copper as cathode. Lastly, we have understood the concept of electrode potential and standard electrode potential. We shall be continuing this topic in our next video and study about the Nernst equation, which is really an important topic. Till then, bye, keep on learning and respect your parents, because without their blessings we can never become successful. Thanks for watching my video. Please like, share and subscribe to Mismatched Tapes for more interesting videos.